the back. What is it?
Left.
Going.
You can't see the door.
You can't see the. This was a view of the road this way here. Yeah. So you got it right, but for the wrong reason. Yeah. Okay. I'm kind of sad I have to go hang out on these elementary school like brain teaser sites now to find stuff.
I heard the door one.
So if it was going this way, you'd be getting on the bus and you'd see a big door here. Right?
Okay.
So you can't see a door, so it must be going the other way. Button is a structure that's very related to what you need for lights out. So don't just sit there and ponder life. Go look at that stuff and even just start modifying it if that helps you. Don't be asking me how to make a button be light or dark. There's enough information there in the example code to tell you the answer to that. And so if you don't know how to do it, it means you haven't looked at that code. I actually do a little extra thing. You know, I don't know what you should do. That's what creative means, right? Find something that's interesting. I'll tell you a sad story. The sad story is, maybe I told you the story, I can't remember now. So I teach 3505 sometimes, which is a software group engineering project course. And sometimes for the final project in that course, which is a bigger project than we're going to be doing, I just say make an educational application, something to teach something. And they have to use a physics engine so things bounce around, and they have to do sprites and animation and all that kind of stuff. Have like 2 plus 2, 4, forget it, that's not creative. So I was very sad that this group had gotten this far in CS, knew all the technical skills, but their creativity was very limited. So I think it's good just to keep practicing, like, what would I do here? What would be fun here? How would I make this interesting? How would I make this a product? That kind of stuff. So anyway, Google around. I don't want to say anything because I want you to kind of just think about.
Did they come up with something creative, or is that like what they finished to go?
Oh no, I denied them. I said they could not do it, and then they had some horrible binary math teaching application or something like that. So it was but I could only deny them so long, All right, well, let's just look at this lights out game really quickly to make sure we're on the same page here. So you have a 5x5 grid. This one allows you to hit new game on here. And don't click these are like ads here, right? So if you tried this and clicked it, you go to some other game, like play this fun game instead. I was like, what? So the key here is also, this thing is lit up. I often have, when I've done this before, I've had people solve it by making it all white instead of all dark. And, it wasn't like a huge problem, but I was sort of sad that, So this is on, this is off. And if you click a button, it and its north, south, east, west neighbors flip, they toggle, right? So it's not that they turn on or they turn off, they turn opposite. So here, if I click here, that one went on, that one on, that one on, and this one toggled off, and this one toggled off, right? So we're flipping things, not just on, off. And that's basically it. You try to click around until they are all off. I would love it if this would just like magically solve and that would look really smart. But and there's an approach that you should read about for solving this, and that is you chase the lights down. So if you go to a light and you click underneath it, and you finish a row, click underneath it, notice they're all dark up here, right? And I click under this light, 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 and I click under, oh wait a minute, that's too easy now. Normally what happens, is, that's right, you get to a frustrating state where it's like this, and you can't click below those, right? So there's no way to turn them off. And then you go look at this Wikipedia article that says, for this kind of pattern, you select a light up here that matches that pattern. I don't know what it is. And then you do that process one more time. And then it's supposed to solve. But I didn't pick the right top pattern for that bottom pattern, right? And your solver button is supposed to tell you what those top ones you do for whatever that bottom configuration is, okay? So rather than having to go look it up, it will do whatever mechanism you think is appropriate, somehow give me the hint saying, set these lights to turn and then chase them down again, right? It doesn't solve it for you, it just says, here's what you have to set the top row to be given this bottom row. All right, so questions on that? Yeah?
Does the solver have to relate specifically to what they have lit up, or?
Yeah, it should look at this and then do some, you know, if it equals this pattern, print out this answer kind of thing. Not give me the whole table of information. Okay?
You just want us to give them like a hint, like you want them to click on start, or you want them to chase the lights?
So if you get to this point and you hit hint, it should say, hey, you should somehow click this one and that one to start off the next phase, basically, and then you have to do all the work of clicking and then chasing it down. Okay? Yeah.
Does it have to show on your?
It doesn't have to show here. You can make that happen somehow. You could have a separate label that somehow shows it, some text. Did you get that answer? Or, okay. Anything else? Yeah.
If they ask for like a hint or click the solver, and it's not just the bottom row, it's also like the top blue one. Will I give like a snippet of hint?
So if you hit hint and it's not in the configuration where only the bottom row has lit things, I think I say then you should say something like finish. I thought I said something like do something, you know, some warning. Don't give a hint to say it's not ready to get a hint yet or something like that. Anything else? The one other key here is that in the memory game, we had a single array of 16 buttons that got laid out on a 4x4 grid. In this case, when you click here, you want to know what your neighbors are. And the easy way to do that is to use a 2D array. Because then you can say, go back by one index in this dimension, go forward by one index in this dimension, go back by one index in the other dimension, go forward by one index in the other dimension. And so you can kind of very easily get the neighbors given this 2D structure. So you should be looking at that runestone assignment that's due that talks about 2D arrays and thinking about how that might apply in this case. We're not really going over it in the lecture that much. I think I mentioned very briefly one thing about 2D arrays, but that was it. So that's going to be key to making this successful, changing that underlying structure, okay? So ponder that issue very carefully. Anything else? All right, let's make some more interfaces. Well, first let's talk about it, I guess. All right, so GUI stuff, we have our JFrame, we have containers that hold things and components that are things we interact with. And the main thing with containers, we need the layout on the container. And the main thing with components is we need some kind of listener to respond to actions. And I think that's the sort of the fundamental story here that you should keep in mind. I think this action performed method has a lot of complexity to it. And it's worth really pondering some of these issues a little bit. So here is a very simple action performed from that memory game, not really the full thing. And there's a lot of subtlety going on that makes it, I think, complicated to understand this. So first of all, we're implementing action performed to be part of this larger Java GUI system. We're implementing action listener, whatever the interface is that we need. And that tells the GUI that we can talk to this class, basically, that events can get sent to this class. things get sent to this class. You add the listener to things like buttons, right? And basically that means that if the button gets clicked, that's going to trigger this action performed. That event gets sent through this parameter here, and we have to then sort of like decipher it in order to figure out what's going on with it, right? So the key here is that we can get the source, in other words, the component that generated the event, through this call, but it comes out as a superclass, as a container class. And a container class by itself doesn't know how to do things. So for example, if I said container button equals e.getSource without this stuff here, I would not be able to call a show value on it because containers don't have a show value method, right? They're just very generic kind of things that they know how to do a lot of things, like resize themselves and handle layouts and all sorts of things like that, but they do not know about this specific method that we wrote for a memory button. So we have to tell Java, hey, this thing is really a memory button, so we're going to cast it using this memory button cast and store it in a memory button type. And once it's in there, then we can call the method on it because it knows about those methods, right? So when it compiles, it says, hey, does memory button know about show value? It does, and so it compiles it. Now, there's something that can go wrong here. What can go wrong with this approach in a bigger system? Some of you probably saw this in the lab yesterday, where it had some problem. Yeah?
Isn't it that you don't get just memory, but all code?
So there's nothing here that guarantees that this e.getSource is a memory button. So for example, when we added a quit button, that was just a plain J button, not a memory button. A plain J button doesn't have a show value on it. So we're not allowed to cast it to be a memory button. Okay? What do we have to do instead? So the problem is you get these action performs, you have this big GUI, all these events are being sent to this one thing, and you need to start thinking about structure a little bit. So what can we do if there's both a quit button that can trigger an action and a memory button that can trigger action here? What kind of thing would work?
Check what button it is and using the if statement.
There's like, several approaches. This is an easy one. If we had the quit button as an instance variable of the class, then we're keeping track of that quit button. And early on in that action listener, we could say if the source is equal to quit button, then frame.dispose. Otherwise, if there's only a quit button and memory buttons, and we know it's not a quit button anymore, we can just go and cast it to be a memory button at that point. So if you put specific stuff kind of first, where you can kind of get rid of these special cases and check that, then eventually you get to the point where it's not a quit button, it's not a hint button, it's not something else, and then it's just a plain old memory button, and you can just sort of pretty safely cast it at that point. You can also use that isInstance kind of call to check to see what kind of thing this really is. Okay? So you can also ask it, are you a memory button or not, before you kind of do this cast. Now, I will also say, at a certain point, we're going to get these action performed methods that look kind of huge. And we don't like having big, clunky methods that do like a million things in it. So pretty soon, we're going to see another way of splitting this up where we're basically making a custom little action listener for each kind of button. So quit button is going to get its own action listener, and the memory button is going to get its own action listener, and we'll kind of break up the code so we're not worried so much anymore about where these all fit. But we don't know how to do that very effectively yet. Okay? So I think, anyway, the problem with this action performed is that it uses that interface stuff. It uses polymorphic kind of things with this casting, where we're going from a superclass that is an object to something more specific. And you have to know kind of what all those mean for this to make any sense, all right? So it's all very terse, I think, and it's a little bit complicated, even though the code's not very long. But there's some subtle things going on here that really check your understanding of inheritance and polymorphic behavior. So kind of ponder this until you're pretty confident, like, I can understand what's going on with this one line kind of deal here. Any questions on that? Like, does that raise anything in your mind? All right. All right. Let's make a flipbook. So I want to have an application that basically runs through a series of images, draws one, and then draws another one, all on top of each other, right? So if you had a sequence of images that were related. You can make an animation of some kind, or like with FlipBook where you draw by hand all that stuff and kind of spiral through it. So let's say I said make a FlipBook. What do you need to be able to do to solve this problem, right? So this is always the key. Do this. How do you break it down into a few things? You don't have to know the answers to all these things, but you have to know at least what you don't know so you can go Google it. So if I want to draw a series of images on a panel, animate them, what kind of stuff do you think I need to know?
How to display an image.
Yeah, okay. We don't know anything about displaying images yet. We have looked at background colors, but that's basically it, right? So that's something we'd have to research. What else?
Keyframe between images?
Well, we're not going to try to do so the animation is a technique where you have keyframes and then they automatically blend between the two of them, so animators don't have to draw like every frame as much. We're just going to draw the images, right? We'll draw what you get, basically. Yeah.
I guess also probably the speed.
All right, so somehow we need to, I'll say trigger the animation, right? Trigger next frame or something like that. So, one possibility would be like, you hit the keyboard with the spacebar really fast or something like that, and each time it would trigger a new image, and then maybe that's one thing, but maybe there's other ways that, are a little nicer or something like that. When I say series of images, what does that imply? What are we going to have to do to use a series of images? This one you kind of know the answer to, but.
If you're able to remember the images each time they add images.
Yeah, so what kind of thing would we, so we need to somehow store images. And what's a reasonable choice for that, do you think? I have 10 images. Array, what else? Array list, let's use an array list, right? All right, so if we can do all that stuff, we can kind of do this flip book where we get a little animation. Let's talk about images really quickly first. So it's nice to use images. If you look at modern applications, a lot of times they might have some sort of icon instead of just a button that says quit or something like that, and those are images, right? A lot of applications use images. For example, here's a medical image, right? Someone's scanned a brain, and you want to display that to the doctor, so you want to take that image and put it in some sort of application. Games, of course, use images. All those little characters running around doing stuff are all images. So if we know how to do images, we can do a lot of fun stuff in applications. Java has several different ways of doing this. One way is what's called a buffered image. And a buffered image basically stores an image and lets you kind of manipulate it at the same time. So it's a nice kind of open class that lets you do a lot of powerful things with images. To represent an image, images are made up of pixels, right? So that's pixel is short for a picture element. I'm not sure where the X comes from, but I guess it just pronounces better, right? So it's not a pickle, it's a pixel. And each pixel is a single color, right? And you put enough of these together and make the pixels small enough, then it looks like a continuous kind of film image or what we're used to viewing. We arrange these pixels in a 2D array of some kind to make an image. So you typically are talking about how far over you are and how far down you are to get to a particular pixel. And you have to know something about the resolution of the image, which is the number of pixels overall used in an image. And sometimes people talk about like a 4 megapixel image or something like that, but more commonly they'll say it's a 3000 by 1500 resolution, and it's kind of give you the height and width along with sort of the overall number. That's a little more useful kind of stuff, right? So a bunch of pixels, and this is also how things are drawn on our screen, right? Our screen has a certain number of pixels, and we set a color to it, and we see things that way. Color is often represented by amount of red, green, and blue. I'm not totally sure if that's because there's some certain underlying technological things that make it easy to represent those colors, or whether it's human perception. So human perception, you have rods in your eye that see black and white. Like at night, you use your rods, and then you have cones. And the cones are triggered by different wavelengths of light that happen to be sort of in the red, green, and blue range. So their peak response to light are those red, green, blue frequencies, but they have other responses as well. So there's sort of actually some innate red, green, and blueness to how we view the world as well. In Java, we represent the amount of red, green, and blue, each in a range from 0 to 255, which matches up with a byte, which is one of our primitive ways of storing information. And the thing, who here does any painting? Anybody? Like mixing paints and stuff? So if you take a bunch of paints and mix them together, what kind of color do you get? It gets darker, right? And that's because it's in a subtractive color space, basically. Paints absorb colors, and so if you mix two of them, you absorb more kinds of colors, and you reflect less, and so you get a darker color. So, sort of confusingly for those that paint, in most computer graphics applications, we're working in an additive color space, and so if you add together a bunch of colors, you get white. So, for example, here's an example of an additive color space. Kind of hard to see, but if I have a red spotlight and a green spotlight and a blue spotlight and shine them together, where they all overlap, I get white. Okay. And so, for example, to get all white, you'd have to say, I want 255 red, 255 green, 255 blue, and Java would make that a white color. We saw yesterday with our background that the color class has a bunch of static class variables that are preset named colors like yellow, and you have to sort of go look up and see what's available, or you just sort of try typing and hope for the best and see, if it accepts it or not. So you can make colors either through those names or by giving it an amount of red, an amount of green, an amount of blue as a number, and it will make whatever particular color that is. So a pixel really is storing those three red, green, blue colors inside the pixel, right? It's not a single number typically. All right, so to draw something, sort of raises a larger question about how does drawing happen at all. So for example, if I set up my J-frame and my panel, somehow it decides to get drawn. Maybe that set visible does something where it draws all the components. But we sometimes have to redraw a window as well. So if you're in a windowing system, when do you have to redraw your window? Like, it's not... It all works so well, you start thinking it's like a physical piece of paper, and you move this window out of the way, and now you see this window. But that's not what happens, right? It's all just drawings on the screen. So,
When you want the image to change?
So if you want the image to change, but sort of even more basically, you have to redraw yourself sometimes. What do you think? I just gave an example of it, really. So if you move your application around, you got to redraw. If you resize it, you have to redraw it. If another window covers it, and then doesn't cover it, you have to redraw it. So anytime you're sort of changing that area of the screen, you need to redraw it. So somehow it knows how to redraw itself, because if I run an application right now, put a window on top of it, and move it, it's going to sort of do the right thing. So there's some default behavior that makes this happen. But we need to intercept this and make sure, and try to add an image into it, so we can add an image into that redraw process, basically.
Can you override it if you wanted to make something stay on screen?
You'd have to change the operating system to figure out what that would be, basically, to make your window be like the super window, right? So when things happen, we redraw our application. And essentially, there's this repaint call that can trigger that process of redrawing itself, all right? Now, in Swing, when you call repaint, it calls a paint method that exists somewhere in that component. So that component somewhere has a default paint behavior. And that paint is actually made up of several things. It says paint component, which is like the things like the button and things like that. Paint the border, because you have to redraw the border so it looks nice. And paint any children, which are any smaller things contained inside you. So this repaint call propagates through that hierarchy of panels and things until everything gets painted properly. And we're going to override the paint component to add in color or images onto our component. All right, so we're going to give it a new behavior inside paint component so that it will draw what we want it to draw in there. Now, this is a little bit of a confusing system because somewhere in your code you say repaint, or that happens automatically from resizing or something like that. And then all these mysterious things happen that are inside the Swing GUI system. Paint, 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 background, paint. children, and eventually it calls this paint component, and for example, we can draw an image on the screen using this call. This graphics G is basically something that's like the screen we're drawing on right now, and it gets sent to this paint component through this repaint process. We always need to call the super paint component to make sure that the panel or whatever the basic thing is gets painted. So this is sort of like the action listener. There's certain things you do in it. So we override this paint component with a graphics G. We don't have any choice of what that's called. That's what it's called. We call super if we're inheriting from something, and make sure it draws the way it wants to draw itself. And then we add in any custom code we want here. And here we're saying for this graphics thing, draw an image of our image starting in the upper left corner, this size. I forget what null does here. All right. Now, if you go Googling around for like how to draw an image on the screen, again, you have to kind of use your judgment because there's a whole bunch of information out there, and some of it is just kind of wrong, and some of it is right. And I'm saying I'm right here. I'm correct. So this is the correct way to do it. So you'll see stuff like this inside your constructor or something. Get out this graphics G thing from your panel and draw an image on it. So this is people that want to sort of like force the issue, right? They want it to happen when I want it to happen. I'm in main, and I want to draw an image right now. That's not the right way to do it, because what's going to happen is you're going to try to draw it, and eventually your code is going to call repaint. It's going to call paint component. It's going to erase your image, and if you didn't say draw an image every time you repaint, it's not going to do it again for you. So you need to tie into the system where we're, again, overriding things and letting it happen as the system wants it to happen, not sort of when you demand it to happen. So you have to kind of work within these constraints a little bit, and it's a little bit frustrating because you're sort of crossing your fingers and say, hey, anytime you're really ready to do this, why don't you give me an image, you know? And sometimes it feels like it's not going to do it for you. All right, so if we want to make some sort of custom panel class that draws images, that's going to be the basis of our flipbook. We're going to add an image in it, and we're going to override this paint component to make it all work. So let's do that. All right, so I have this image panel basic. So this is a class that knows how to draw an image on itself. It's a panel that knows how to draw on itself. It has all the behavior of a panel, so we can actually add other things to it if we want to. So we are going to extend JPanel, right? And then we're going to provide some new capabilities for this derived class. The thing we're going to add to it is the way to draw an image. If we're going to draw an image, we need to store an image. Let me make that bigger, sorry. All right, so we're going to store an image as a private instance variable of this class. And it's a buffered image. That's the one we use in here to draw things. And in the constructor for the image panel basic, we're going to take in an image. That's the image we want to draw. We're going to assign that image to this instance variable. So again, this image here is really this .image, right? It belongs to the instance of the class. And we're going to say how big this thing is. And we're sort of going to assume that this, you know, we want our panel to be as big as the image is. So we say, hey, if you can handle it in your layout, try to make it as wide and high as the image. That's what this set preferred size kind of thing is. And again, I'm really calling that on this image panel basic, right? Saying how big this should be. So in some other class, I could include this class and as a panel, and if it knows how to draw an image on itself, then we're all set. We can just include it and draw this image. So again, to do this, we're going to override the public void paint component. And again, that's not anything I'm inventing. That's the exact name I need for this to work in this larger repaint system that Swing has. And I take a graphics G object as part of the method. And in here, again, the important thing is to first, remember, I'm inheriting from a JPanel. So I want to tell the JPanel to draw itself first, because maybe it knows how to draw in its like background color and stuff like that. I'm going to override that, but I want to make sure it's actually there. Paint component, just singular, with G. And then I'm going to draw my image on it. So pretty easy. Draw image, all sorts of choices here. So I take my instance variable, image, and then start in the upper left corner, upper left corner, and if you don't give all these things, it just draws it as big as it is, basically. So I'm going to erase all those things. And I need to say it belongs to this class, essentially. All right, so I'm going to draw this image, and it's on me, on this thing. All right, that's really all there is to it. So drawing an image is not that bad. Let's make an application that actually uses this. So show image, panel basic. In here, so this is my main application where everything runs from. I'm going to have an instance variable that's a frame and an instance variable that's an image panel basic as a panel. So instead of a JPanel, it's going to be an image panel basic, which inherits from JPanel, right? So it acts like a JPanel, but has more capabilities. So in my constructor for show image panel basic, I'm going to take in an image, and I'm not using it yet, but I'm setting up my frame. So I make a new JFrame, I set its default close operation, and what we need to do at this point is add that panel onto it. So I'm going to have my image panel basic. Oh wait, I already made an instance variable here. Panel equals new image panel basic, and I needed to pass in an image, so it knows what image to draw, and I need to set the frame's content pane to be that panel. So remember, JFrame has a place for a title, a menu bar, and then basically a panel to hold all the other stuff. And you say what you want that content panel, they call it pane here, to be by giving it something that draws in that area. And then I need to pack the components, and I need to set visible true, and down here in main I'm going to try to read in an image and send that image to the constructor for this application, and otherwise print out current load file. All right, so main's just kind of grab the image, it kind of kicks off this constructor for this JFrame application. The JFrame application comes up and sets up its normal basic stuff. The only thing of interest here really is that it adds in this custom image panel to be the drawn part of the application, and then does the cleanup kind of stuff, packing and setting visible. All right, so there's always this all, they all follow the same pattern. You just have to kind of like carefully, don't forget anything, otherwise it won't show up and you'll be sad, right? And then you have to just remember what you forgot. Kind of like my get layout on the memory thing. All right, so if I run this, it's me. All right, so that's as good as it gets. Let's now make it a little more like a flipbook. There's only one image, and our panel only knows how to draw one thing. So let's modify both to be a little fancier here, okay? So let's start with the image panel and give it that array list of images to use and a way to change between the two different images so we can animate it. All right, so in here, right now we have this buffered image, and instead let's make a private array list of buffered image. And we'll put it in, and I'm going to get rid of this thing here, and I got to give it a name. Images. So I have multiple of them. Now, if I have like 10 images and I want to draw 0 and then 1 and 2 and then 3 and 4 and 5 and 6 and 7 and 8 and 9. And probably start back at 0 again, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What else do I have to know about to do that successfully? So I want to draw 1, and then I want to draw 2, and then I want to draw 3, and then I want to draw 4.
The image index.
I have to know which index I'm at, right? So I have to know which image is on the screen right now. So I can go to the next one and pull that one up. So I'm going to have a private int, and I called it frame number. And again, that's coming from animation where you have frames of animation, right? All right, so let's see. Do I want to start this? I need to initialize my images. So images equals a new array list of buffered image. It starts off empty. And I want to take images and add image. So I still only have one image here. I'm creating an array list to hold it and adding one image to it. I don't need this anymore. And here, I'm gonna assume that all my images are the same size, so when I'm flipping through, it's not like jumping around its border. So we'll just make the preferred size be the size of that one image and call it a day and assume, the rest will be also that size. When I draw it, I don't want to draw image anymore. I want to draw images. And what image do I want to draw? I want to get out the image at frame number, goober. Right, so an array list, instead of using the square bracket there, we're using .get to get out the item at this index here. And so I haven't initialized frame number, so that's a bad thing. I should say that frame number equals 0. Start at the first element of that array list, right? So now there's two things here. We got which one we're doing here, and we have one image. If I want to add another image, how can I do it? I mean, I could send in an array list of buffered images here. That'd be one approach, but sometimes I don't like to know all that stuff in advance. I want to kind of build this FlipBook up incrementally, So what would I need to do to let another application add an image to this list of images here?
You make a method to add images to your images list.
I need to provide some interface through this class to get to this private images. Images is private, right? Other code can't get to it. So I need to add in some public void add buffered image, and in here I can say images.add image. So my other program can then create one of these image panels and then add a bunch of images to it to give us more information. Okay. That's maybe enough to get started. It's not everything we need, but let's go back to the other class and try to stick 2 images on this thing and make something happen eventually, okay? So, how do I want to structure this? What did I do before? Let's see. Down, let's see, buffered image. All right, so in main, right now, we are reading a single image. If I want another image, I got to read another image, basically, right? I don't have any choice about it. That's how you get images in here. So I'm going to add in another image. I'm going to still make my application here. And let's see, it's going to work. I'm a little nervous about this, but I'm going to say app frame, which is our image frame, add image 2, which I didn't name correctly. so it doesn't like that. Why not? Doesn't. I want to add. Did I call this image? Add. That should work. Change something here. Image app. Show image panel. Sorry, frame. I have a frame here, right? Frame. Oh, it's the panel. I want to add the image to the panel. The panel is the custom image thing. All right. All right. So if I run this, I think it'll still work, but only still give me one image.
Yeah, we can help.
Oh. All right. Thanks for calling out there. All right. Try to run this, see if it works. All right, still this. This thing apparently has two images in it, but we don't know how to get to the other image yet. So let's try to add that in there. So, all right, let's go back to here. Right now we're always drawing frame number, and frame number is always 0. So if I want to get to the next image, what can I do? Let's just kind of hack it first and do a frame number plus plus. So once we draw 1, we're going to do it. Then we're going to say.
Make it go through too quickly so you don't actually see it.
Well, it's not going to draw. We don't know when it's going to be drawn, I guess, right? So let's kind of see what happens here. So something made it go to the next image already. Why are you laughing? I don't understand that. And if I were to somehow force another repaint, then it's going to try to go through there again and draw the next image. And it's unhappy about something. It's got all this repaint stuff. And I think what it's complaining about eventually is that I'm using an illegal, my frame number is too high. Maybe that's a problem. I'm not 100% sure that's a problem, but we'll pretend that's the problem. Okay, so somehow this is going to go from 0 to 1 to 2 to 3 to 4, but there's only 2 images, right? So we need to do a little bit different technique for that. And as just our hack for that, I'm going to change this to be, let's do frame number equals frame number plus 1. So that's the same as before. But now we use that mod operator that I think we've run into a little bit over. Right? Mod says, give me the remainder after dividing by this number. And in practice, if I have mod 2, then it says go 1, 2, 0, 1, 0, 1, 0, 1, 0, 1, because this big number, like 5 divided by 2, has a remainder 1. 6 divided by 2 is 3, remainder 0. 7 divided by 2 is 3, remainder 1. So that remainder thing just sort of cycles back and forth, 0, 1, 0, 1, 0, 1, 0, 1. So I'm going to say mod 2 here for now. I could do array list size if I wanted to be better here, because that's the same thing. And if I run this, and now if that's disturbing, yes. So actually, this tells you when those repaints are happening, right? It's happened a lot. Like, the reason when this window smoothly animates around like this, it animates smoothly because every time it moves a pixel, it's causing another repaint and redrawing the thing. And that also happens, let's see if I can Sometimes these windows do tricks, like they actually hide the thing underneath and don't repaint it. They just slap the image that was covered back on top of it. So maybe that's what's happening here. But we have this, yeah, this repaint. So notice I never called repaint anywhere in my code, but somehow that repaint got called, and it's because the system, again, is generating these repaint events to make it happen properly. Okay, I was going to add like a cool slider and other stuff to this, but I think we can only just kind of get started on that. So, yeah, question first?
If we were to add another image, that would still only cycle through the first two because...
Yeah, that's why I really should...
That was just kind of like a general way to make it go.
I should make this images.size, right? Size is 2 in this case. If you add another image, it would be 3, and it would go 0, 1, 2, 0, 1, 2, 0, 1, 2. All right. So let's leave that for now, and then we'll maybe add a whole bunch more interaction to this thing on Friday. All right?